y'all don't know, my name is Christopher Lopez. I'm a security researcher at Kandji. I'm even wearing their shirt. Couple things outside of spending too much time reversing. I like jujitsu, running, video games, drifting. If you're into any of that, very easy to spark a conversation. If you're interested in more reversing content, I have a YouTube channel. It's not a big deal. I don't even edit anything. It's just reversing stuff. So if you're interested, go check that out. So the goals for today, write as minimal slides as possible, which is what I did, just 3, and just demo the whole thing. So we're going to be looking at a sample that was talked about recently, and just want to talk about our goals. I think it's important for reversers to share the methodology of how you go it from like a file to determining how it works. Just to talk a little bit about where this came from. I was at Patrick's class at OBTS, shout out. And a friend of ours showed up at the class and he just started reversing in the middle of the class, Arnaud. And it blew me away. I was like, whoa, that's like how it works. And that's so cool. So I'm going to try to like do that as well. So our goals, we're going to use an existing write-up to help tailor our analysis so that we don't spend too much time up here. Number 2, we're going to find potential opportunities inside of this write-up to dive deeper into parts that weren't really covered. As someone that writes blog posts, there's always something that I don't cover entirely. So it's good to find like those little opportunities to dive deeper. We're going to spend time understanding how the application works. And of course, because we're reversing stuff and that's cool, we're going to have fun. So I'm going to just start Binary Ninja and we're going to talk about this. This is the file that we're going to be focused on. It's probably a lot on screen. Hopefully it can be seen okay. And this file comes from a recent blog post by Jamf. I have a lot of friends over there. This is not a competitive thing, okay? I'm at Kandji, so kind of interesting. But they have an awesome blog post recently. I think this was like a week or 2 ago. Yeah, July 16th. So shout out to Jamf and Moonlock because they both helped with this. And we're going to talk about this sample. So as a reverser, this is exactly what I want from... Not working. Hold on. 1 second. I'm in here. Share. Entire screen. Okay. Appreciate y'all. So blog post. We're good. Don't know what happened. All right. So beautiful introduction here, in my opinion. As someone that writes blog posts too, they give you a hash in the first 3 paragraphs. That's awesome. So if you work for a company that has access to like VirusTotal licenses, it's easy to find these hashes. In this example, I just uploaded this hash to a free website that you can go and grab this file if you're interested and, you know, poke around at it. But here's what I want to focus on. They do a good job of explaining the overall threat, but there's one part that I saw that I was like, that's my opportunity to have some fun. They talk about the stage 1, so the dropper. The dropper in this case ends up dropping a stealer, which is kind of boring now because there's so many stealers for macOS. But still, this dropper, the beauty of it is it's written in Swift UI. That's fun to analyze. And they even have a little GIF here, which is pretty cool, that shows like how it works. So that's interesting. It pretends to be some like shop management application. Of course, it prompts the user for their password, and then it installs the stage 2 from a command and control server, and it continues executing that other file. So again, what's going on? I'm not doing nothing, I promise. Okay, so right here, this is the point that I wanted to make. They outline the C2. This is awesome for building detections, right? And they mentioned that it uses native Swift APIs. Also a lot of fun. And then they mentioned that it downloads an application or another script, and it ends up executing chmod to change the permissions of the file. And That's all that's really covered about the downloader. They do a good job of covering the script and all the other stuff related to this threat, but this is the opportunity to have some fun. This is what's covered about the application. So now we're going to dive into Binary Ninja, which is the best tool for this, in my opinion. They're awesome. And this is what it looks like when you first open up a Swift application. It's very ugly. All the symbols are mangled. What do I mean by that? If you search over here and you look at symbols for Swift, you'll see that there's mangling. So this is used by the compiler to make symbols unique in order for Swift to do what it needs to do. We don't need to know all that. We just need to know that there's tools to help with this, because that will aid in our analysis since we need to understand like how this works. So there's a plugin that's available on Binary Ninja's like plugin manager, and it's super simple, and it's called Swifty Mangler. And this is going to make things pretty, and we want things to be pretty. So Swifty Mangle, as we see, things are a lot nicer. Look at all that. That's beautiful. Perfect. Okay. And then sometimes it doesn't help with the UI. You have to kind of like click into something, come back, and boom. So we're at the start function. The first thing that I like to do, I know that this is a Swift UI app, so it has a UI. So the start function is kind of weird. It's not like a command line tool where you just continue from where it starts. It has a whole runtime thing that we have to worry about. But if you don't know that, in Binary Ninja, you can go to triage summary, or you can use command line tools, which Patrick has in a bunch of his blog posts. And you can see here that it imports the Swift UI framework library. So we know that this is a UI app. So the next thing that we need to worry about is, where do we start our analysis? Now, this is something that I've had a lot of questions about. You get a file, what do? You can't continue from start. So what should you do? Well, having looked at other samples in the past and knowing that this spawns a process for chmod, I should expect this application to spawn a process. There's only a few ways in which a Swift application can spawn a process, and usually a lot of malware authors are lazy, so they'll use a lot of the same methods that we've seen in other samples, and usually that's done with like an NS task. So we just look that up really quickly. NS task, if I can spell. So this allows the developer to create a sub-process from a GUI application or a command line tool. And this is what we're going to look for inside of our symbols to see if maybe that's how they spawn chmod. So NS task. Beautiful. So we do see a reference to the Objective-C class for NS task. Now you might be wondering, this is a Swift app. Why is there Objective-C? Because Swift is most likely going to have Objective-C. Objective-C is beautiful, so we're going to spend time with it. And if we double click on that, we go to where there's a reference to this. And if we just hover over and click on the address where this is referenced, we can go to the Objective-C class ref section of the binary, and we can see other potential interesting things for us to look at that this application uses from an Objective-C perspective. And we have access to that NS task object. So now to see how it's used, we can go again, click on the address of this reference, and Binary Ninja does a good job of showing like code references, so cross references to this NS task. And we have this subroutine right here that shows this NS task object being referenced. So now we can start playing and having fun. So we know that this is going to spawn NS task. So what a lot of reversers like myself do is we make little notes for ourselves. And one way that I do that is I rename subroutines often. So I'm just going to like rename this NS task. And now when I look this up, I can always see that I have this reference here, and I can remember where I was when I was analyzing this, which I often forget when I'm looking at files. And now we can start diving into how this works, and we can start changing variable names and understanding what this application might do. We know it talks to a command and control server, it downloads some file, and it ends up running to chmod.x. So if we're being lazy and we're just trying to make this quick, we can see chmod down here is already being referenced in some kind of string copy. So that helps with our analysis. And I just want to show like the act of going in reverse engineering. So I'm going to rename this. This string copy essentially means that this chmod plus x, which is setting the executable bit for whatever file is being referenced, is this object. So I'm just going to rename this object to chmod. Now I have reference to this object, and I can see where else it was used above. This reference to the NS task that I was talking about, we see this Objective-C alloc with zone being passed as an argument to Objective-C message send. Just something to keep in mind if you have not seen Objective-C, the way that methods are passed to objects, you use this function called Objective-C message send, and you need to pass the class object as the first argument, and then a selector, which is the method as the second argument, and then any other arguments are after that. So you'll often see this Objective-C message send, and we can see the NS task class reference, and we can see the init method. So did that go away? Yes. Not sure. It says that I'm sharing. Okay. It's too much. Binary is too much. It's too exciting. Okay. So that tells us that we're initializing an NS task. So I'm just going to replace this object, which is the struct Objective-C object type, and I'm going to just call it NS task. Now, Swift is really weird when it comes to strings, so we need to be aware of that. We can see this method here, this URL.init. So we're creating a URL, but it's not a URL like a URL to a website. It's a file path URL. And we can see the ASCII bytes for a specific string being passed as an argument to this. So we need to figure out what this is because it's used later. So if we just right click on this and display as a string, we'll see that it's referencing the ZSH shell. Now, strings in Swift are weird. They're structs. And if they're less than 15 bytes, they're a small Swift string, and they're always going to be starting. They have two members to this struct. They have the ASCII bytes themselves, which is this bin.zsh. I can go down. And then it also has the size, which is this 0xe8. So it's 8 bytes long. This URL path is initialized, and then it's passed to Objective-C to change the type from a string URL to an NS URL. And that's what this object is. So we're going to call this ZSH Objective-C object. Okay, so we know that ZSH is going to be used for something. So it's going to spawn a shell, which matches what we saw before here, talking about how there's a shell that's spawned. Okay, so we're on the right track. The next thing that we're going to talk about is this function. It's called Swift alloc object. And this is essentially creating an array of a specific size that's going to be used to pass arguments to the NS task object. So we're just going to call this NS, or we're going to call this arg array. And every time you change a variable name like this while you're reverse engineering, you'll see that it makes changes further down in line, which will help with your analysis as you continue, which is very useful. So we're still setting up this NS task object, which is going to spawn this chmod, and we're going to continue from here. If we see this, we can try to change this to make sense of it, and this ends up being more strings. This is a small Swift string, so we can display this as a string, and we can see that this is for a backslash and a space. We're getting the URL path getter for chmod, and we're doing a string append here. So we got the path, and that's going to then be passed to this append method, which this is another string. And from here, we have another string append. So all this is just putting together the chmod plus x plus the arguments you need to create this task that's going to spawn a new process. And if we go down, we have this array that we're now converting a Swift array into an Objective-C NS array, and this is going to be our NS array for the arg array. Not the nicest variable name, but that works. And we can see that we're passing now to our NSTask object to set arguments with the NS array, and we can see that chmod is passed there along with this variable. So this is going to set this up. It's going to set an NS pipe. Cool. So this is NS pipe. Just rename that. And it's going to launch this command. Okay, so now we know how this works. It sets up an NS task, and it launches this chmod. It's going to modify some file. We don't know what that file is yet. We just know that this is what happens here. So now this is part of reversing, right? So where did this come from, this function, and how do we understand what calls this? So we're going to click on the NS task, and we're going to see that it's called from this function down here. So we're going to go here. Now we need to make sense of this function. We know that at some point, there's an if statement that will then call this NS task preparation function, which will set that new process up. But what does this do? So if we look around, we can see references to what are strings for Swift strings. If you've seen these before, let me just clear this up. This is an example here of a large Swift string. So large Swift strings are really weird, and you need to do a little bit of parsing to understand it. But luckily, you have the Python. Oh, come on. Here we go. Luckily, you have the Python API that you can use to make sense of these. So if you do like a bb.read down here, and you pass in an address, you have to pass in an offset, and then the size of the string, which in this case is going to be 23 or hex 23. So 0x23. Oop, hold on. I got to hide this. There we go. Every time I hide the thing, it tells me I have to reshare. All right. Let me just move this up because I can't see with this thing. I can move this thing? Oh, thank goodness. All right. I don't know how to use Zoom. It's all right. Okay. So continuing. So we have this bb.read, which is something that you can use in Binary Ninja while you're analyzing a file. You can just basically use Python, which is great. And we're going to make sense of this Swift string to understand what this is, to see where we are and when this calls this NSTask method. So this will tell us, and then the length. So 0x23. So this is an NSURL response here. We need to add our offset to get to the string, which will be plus 0x20. And fail to download order data is the string. And these are Unicode bytes that we're not worried about. And this is a GUI application, so it makes sense that there would be like symbols and things. So this is related to some kind of failed event. So there might be some error handling here, and we can assume that this error handling will be printed out somewhere. So if we scroll down, we might see like a print function, which we do. So it looks like we will go here if something fails. So we need to understand what leads to this function to know what happens. So we're going to go back, we're going to reverse, and we're going to come, let's just rename this so we know where we are. NSTask again. And we're going to come here, and now we have more Objective-C code. So we can tell that this function that we were just at will spawn this NSTask, which will spawn a new process. And we're going, right, we're going back, we're reversing, and we're going to do again for fun. And we know that this is part of a block. So a block is like a contained set of code that you can pass around in Objective-C. And usually that happens as like a completion handler. And that's what we can see here. We have this download task with URL completion handler, which means that we're probably in the function which will set up the connection to the command and control server. So we're almost there. And that's awesome. So we're going to skip all this because we're not too worried about all this setup. Swift is very verbose, and we don't need to know all that. We do see references here to another Swift string. large Swift strings can start with the 0xd. And if we display this, we'll see the same reference that we were talking about before. So we're going to just change this. We're going to grab this address and we're going to put it right here. And this is of size 1B. And we're going to get access. And this is the command and control server that was talked about in the blog post. So we know that this is going to be used at some point to communicate with this command and control server and download this file and then run chmod against it. So we're on the right track. So for anyone that's not familiar with URL, NS-URL sessions, we're basically creating a communication via the network to essentially talk to this C2 and download a file. So we're going to rename a couple of these variables. This is going to be an NS-URL session. We're bridging this URL that we created up here into an Objective-C object. So this is going to be our command and control server. Command and control. And we have this block. It looks a little bit weird, but blocks are strange. Essentially, we're grabbing this subroutine or this function, we're putting it inside of a block, and we're going to pass this block to this download task with URL completion handler. So what looks strange, if you haven't seen like a long method name like this, in between each one of these colons is an argument, and we can see the arguments passed here. So we have an NS-URL session object. We're passing this download task with URL, which will download a file at the specific URL. And we're passing in the URL, which is the command and control server. And we're passing in this block that will then execute after this successful download happens. So what this means is connection to C2 for download. You don't have to write this long variable name, but I like to do that. And this will then spawn with this resume. So what did we learn? We learned that this SwiftUI app leverages NSTask in order to download, in order to spawn the chmod process on a downloaded file, which means that this downloaded file is passed as an argument to the completion handler in order to spawn this NSTask. So we learned how it actually completes that action by spending a little bit of time inside of Binary Ninja. And the way that it does that is leveraging NSURL session class and passing in a URL, Swift URL that was hard-coded in the binary in order to convert that into an NS object URL and then pass that to the NSURL session, download the file, and then continue from there, change the permission, and then execute the stealer. So that was kind of a quick one, but I think it encompasses a lot of what happens on a day-to-day for a reverse engineer. Essentially, just to kind of recap, look for opportunities for your analysis to continue outside of a blog post. Look for good blog posts that demonstrate what happens, and then dive into it. Look for resources that the file is available at, and you can just download. Like, for example, Patrick has a bunch of blog posts and a bunch of malware samples on his GitHub, which is how I learned. And I think we're good. Cool. Okay.